Here we aim to use linear approximation to estimate the cubed root of 65. And I'll start by outlining the approach. We'll start by defining a function as the cubed root of x. Next, we'll find the linear approximation L of x at a point near 65. And finally, we will plug 65 into our linear approximation to get our approximation of the cubed root of 65. The key to making this whole thing work is to pick a clever a to start with that is near 65, but that we also know what the cubed root of it is. Can you think of some number near 65 that we know the cubed root without having to break out a calculator? How about a equals 4? Okay, so note that the cubed root of 64, with a little bit of thought, we can deduce that that is 4. Hopefully you don't have to break out a calculator to do that, but even if you do, it's not the end of the world. 4. Okay, so let's define a to be 64, and then we know what f of a is. F of a is 4, and we will use our equation for the linear approximation, which is L of x equals f of a plus f prime of a times the quantity x minus a. We know f of x is the cubed root of x. Okay, cubed root of x, which we will rewrite as x to the 1/3, so it's easier to take the derivative of. And I think that's all we need for now. So let's take that derivative and see where we can go with that. So f prime of x, okay, is 1/3. That's just the power rule. X to the minus 2/3. We can rewrite this as 1/3 x to the 2/3. But we want to be able to evaluate this at 64. We want to evaluate it at a equals 64 because we're trying to find f prime of a. All right, so f prime of a is, well, a is 64, is f prime of 64. Well, that's 1/3 times 64 to the 2/3 power, which we can think of this as 1/3 times, times the cubed root of 64 quantity squared. Well, the cubed root of 64 is 4, squared is 16, so that 1/3 times 16, which is 1/48. So that gives us our derivative here, which is the slope of our linear approximation. Let's put everything together and get our linear approximation. So we have L of x equals, okay, f of a we decided was 4, plus f prime of a, 1/48, times x minus a, but remember a is 64. There is our linear approximation. Okay, let's use this to estimate the cubed root of 65. To do that, we evaluate L of 65. All right, what do we get? 4 plus 1/48. 65 minus 64. Okay, well, that's essentially 4 plus 1/48. Put that into a calculator. We get about 4.0208. Well, I wonder how good of an approximation that is. So far we've been pretending that we don't know how to do the cubed root of 65 on a calculator, but let's go ahead and compute the cubed root of 65 on a calculator to see what that gives us. And if we do that, we get 4.0207. So wow, look how close we are with this weird linear approximation. No cubed root necessary, nothing like that. This is just a line. It was very simple to plug in and compute. And look how close we can get to our actual value of 65, of cubed root of 65. So pretty amazing method, really.